Hey guys, I hope you're well. I want to power this HW-16 up for the first time. I realized, I've got all the parts that I need for this radio and for this radio. But I realized I'd be foolish to tear into this thing before I at least power it up and see what it does. Will it make smoke? Will it make a nasty loud hum at any volume setting? Will it work? Will we hear receiver hiss in the speaker? What say you? Some combination of the above? Hum plus smoke? Receiver audio plus smoke? I can't make fireworks. Why? Well, I'm starting at 0 volts with this Variac. Let's follow the path of the juice out of the Variac into the isolation transformer. Out of the isolation transformer into the dim bulb tester. Out of the dim bulb tester into the rig. When I power it up, it'll act differently than a radio that uses a vacuum tube rectifier. This does not. This uses diodes. So as soon as I start applying voltage with the Variac, you should see activity on the ammeter. I'm very nervous right now, and I don't know why. This meter will show us the AC voltage going into the rig. That's what those 2 banana jacks are for. Why didn't I put an output voltage meter on the dim bulb? Well, I didn't want a stupid digital. I didn't want a $2 digital voltmeter. I wanted an analog meter. And that's the only case I had, and there was no room for an analog meter, so thus the jacks. That's the AC voltage going into the rig. This is our B plus voltage. When we reach a state of fully powered up, we should have about 700 volts. When this one shows 120. I think in the mid-70s we were now using 120 volts. That was our standard. I think so. But I digress because I'm nervous. The only reason I'm nervous is, will it work? What say you? What are the odds? I had to replace 2 parts in it so we could do this. Well, I had to replace that power resistor. It was open, and it's in the power supply. That electrolytic I replaced just because it was the only one on that board, and I wanted to change it. I had it on hand. So, with Scout's help, he's going to supervise this clown show. Hey, Scout. Hi, buddy. Let's get going, shall we? I'm gonna put you on a tripod and see what the dang thing does. Hang on. Okay, I debated about what to have you look at. Initially, I'm going to have you look at this view, and as I apply voltage with the Variac, because if the radio has a dead short, you'll see it on the light bulb. Okay, so I'm going to reach over, click the radio on. Okay, click the Variac on. You see no voltage on the isolation transformer yet because the Variac's turned all the way down. Turn the dim bulb tester on, select the low power load. Here we go. Let's apply voltage. AC volts out of the dim bulb, B plus over here. You won't see it, but I do. A slight increase in current flowing into the rig. I'm up to a voltage of 20. The dim bulb tester has a bright lamp lit. The radio has a dead short. Although it is generating B+, it's up to 123 volts. It's possible that this transceiver is just presenting too heavy a load to use that 43 watt bulb. I'm going to give it a little more AC voltage. Keep in mind, the radio can't make fireworks. If it's a dead short, it's the same as closing a light switch. If it's a dead short, that lamp will come on full bright. We're showing B+ voltage though. We're up to 160 volts, B+. Let's keep going. It's still only drawing 0.2 milliamps. I'm going to reposition you and let you look at that ammeter as I increase the voltage further. One moment. Okay, so you can see we're drawing 0.2 amps. The AC input voltage to that rig right now is 40. The B+ voltage, 206. Let's increase this voltage further. Now, in an old rig like that, the electrolytic capacitors can reform. You slowly apply voltage to them, ideally in steps, and you let them sit there and soak at each step. You don't do what I'm doing now, but this helps. I see we're up to an input voltage of only 46 on the rig. B+ is 235. Let's try to give this thing some more power. The current isn't coming up that fast, but it's indicating a direct short, or nearly so. Okay, I'm turning the variac back down. I maxed the variac out, by the way, just then. I almost inputted 140 volts. Now I'm inputting 120 volts to that dim bulb tester. I'm inputting 120, it's outputting 60 because of the lamp that's lit. Hang on. So the AC voltage into the rig is 59. The B+ voltage is 300. It's possible that rig presents too much of a load to use that 43 watt lamp. Pause you, back out. I just noticed the rig is starting to show some light. The dial lamp is lit. Let me put you back on the tripod. So it's possible that the rig is working fine and that it just presents too big of a load to use that 43 watt bulb on the dim bulb tester. So let's give it a more stiff, serious load. You can't tell on the phone, probably, but that bulb is much dimmer than the other one. Boy, that rig is asking for a lot of current. The ammeter is up to just under 0.35 amps. I'll show you the meters. AC in to the rig is now 78. B+ just under 400. Look at the AC input voltage to the rig. That's with a 71 watt bulb. Okay, what is it? 78 volts. Select the 43 watt bulb and it drops to 59. So at this point, the rig is seemingly powering up. And so I'm going to bypass the dim bulb. Now this is where you can have fireworks. When I bypass the dim bulb tester, we're going to apply full voltage and full current to that rig. We'll still be seeing the current it's drawing on my ammeter. Here we go. Nervous. Boom. Let's look at the ammeter. Hang on. It says we're drawing 0.8 amps. How many watts is that? 0.8 times 120? It's quite a bit. I don't think this rig should be drawing 0.8 amps. Let's look at the rig. I'm going to pause you. Oh, by the way, we're now inputting 120 volts to this rig. In our B plus voltage, we are expecting 700. We're getting 655, which is reasonably good, given that the capacitor filter caps are the original ones still. Question is, how many volts of AC is riding on that? You want to see? Let's see. The auto range is bobbling around. Let me lock it into a range. Under 5 volts AC. Oh, that's quite good. That's quite good. The ripple is low. The caps might be semi-okay. When I remove them to install the new ones, I'll check them. But hang on, I pause you. And so that's what this dim bulb tester let me do. It let me power up the rig in a controlled, limited fashion. I see that we're now dropping under 0.8 amps and we're down to about just over 0.7 amps. As these capacitors are forming up, the current draw is dropping. I smell heat. Hang on. Okay, I smelled heat. And I stood the radio up on end, and the heat smell wasn't coming from beneath, which is good, given the nightmare of electrical connections under there. And by the way, at the end of this video, I'm going to show you some pictures that I took of a couple problem areas under there. The source of the heat is that audio output tube right there. It's cooking, too hot to touch. And typically what happens in an older receiver like this, for example, the coupling capacitor to the grid of that tube, if that coupling cap is leaky, you'll start applying voltage to that grid and driving that tube into conduction, turning it on partially or fully, in this case maybe. So we'll address that problem after I've replaced all the parts that I plan to replace. So far, so good. Power's up with no smokes. Might have been if I let it run long enough. But yeah, I can apply full power to this radio. I can bypass the dim bulb and not have any fireworks. So that's good. This was in terrible shape. Probably the worst I've ever seen. No doubt the worst I've ever seen. What I wonder is if this radio ever worked at all, ever. Given the problems I found, I can't imagine it would. But yet I see signs that it was, and signs that it was repaired. For example, 12AX7 from Svetlana. When did Svetlana start selling vacuum tubes? In the 90s? If so, that means in the 90s somebody had to replace a tube in this rig. So anyway, enough talk. It's time to replace all the parts that I plan to in these two radios. And I'll take it from there. Okay? I'll talk to you later, guys. Bye. Hey guys, I hope you're well. This is the second time through. The first time through, I forgot to start my screen recorder. What a drag. And this is a schematic of the power supply in the HW-16. And I want to talk about, not this specifically, but some wiring nightmares. One more example of a wiring nightmare I found underneath the rig. And so I want to talk about that. Okay? You might look at this. You'll have to follow my pointer, by the way. Now, you might consider the AC input to the radio. It's potentially deadly as it is, but these are the changes you need to make it safe. So with that, let me figure out what I'm doing here. Let me bring up pick one. There we go. Classy, huh? Follow my pointer. This is the area we're going to zoom in on. I keep wanting to point at my screen with my finger. That's the area we're going to zoom in on, okay? Here we go. Well, let me say this. This coax right here where my pointer is, that's the wire we're going to be talking about. It sneaks between two pins of these transformers, like this. Now, this is one terminal of the transformer. Here's the other terminal of this transformer. Look at the wire, how it's jammed in between those two terminals. I'm surprised the radio worked, because when I fixed this, both of those terminals had shaft right through the insulation, but they must not have been touching the shield, because if they were, it would have grounded out whatever signals are present. You know, that's pretty bad. That's real bad. Next picture. This picture shows the blue wire. That's all to be gained from this picture, but look at its meandering route. It literally winds around that coax that we just talked about. When I moved that run of coax, I had to disconnect the blue wire and unwrap it from around it. Oh, what a drag. What a drag. Next picture. This is an example. Now, my green arrow here is pointing at the area of interest. These two resistor leads go to the same point up by this choke. Okay. This tan wire down here where my pointer is, that's the one of interest. That's a power supply. That's a transformer winding wire. Makes you wonder how many volts are on it. 700. Look how it sneaks between these two resistors and then carries on its way. He literally ran that wire through between two component leads. Why? Why? That's such bad practice. Next picture. That's a closer up view. And again, this arrow just points to the area. It's this tan wire down here. Okay. Let's see. Is there another picture? Yes, there is. Now, this is a picture of the power supply area. That schematic you saw in the beginning, this is it. It's a nightmare. But as I've drawn this thing all out, okay, this is how I do this. When I restore a radio, I draw it out, and then I'm free to disconnect all the components, disconnect the wiring, and remove those capacitor cans so that I can attempt to restuff them. Yeah, so that's what I do, and that's where I'm at. I've drawn it out, and I'm ready to disassemble this power supply section and have a little fun, have some mechanical fun, and try to stuff the caps. I hope you're well. You guys take care, and I'll talk to you later. Bye now.